Hey guys, making Android app is so much harder than Ruby on Rails. But anyway, I can now let my Flutter Android app listen for incoming serial port data. Let me show you how to do it. This program runs on a 10.1-inch Chipsee Android touch panel PC, and I let it talk to this 7-inch Android PC through RS-485. Following our code from last video, the home is a bottom navigation with two screens. If you don't know this widget, you can watch the video from Flutter team. I made a little bit modification to the last video's code. You can download this code from our GitHub repo below. The main difference is I set a timer in init state and I moved the dispose logic to deactivate. I'll show you why I did it later. So this is my initial UI. It's an empty screen with a scrolling list. There is a received list of strings, and whatever is added to the list will be displayed in this list view. Such as I can add hello world, hey Chipsee, and you should see them appearing here. Oh, and this is a refresh button. It will set received list to be empty, so there will be nothing on the screen once I press it. Next, I should decide which RS-485 ports to use. According to our Chipsee document, there are 2 or 3 RS-485 ports on each device, and because I'm lazy, I use RS-485-4 on both devices. They are all /dev/tty4 in the Android, so I can just hardcode the TTY name in my program later. Then let's get to our topic. So we need to import our Flutter lib0port.dot package. We can write serial port port equals serial port /dev/tty4, and then we configure our serial port. We can write a function init port. We open the port with port.open read write, and then we configure the port with a baud rate and 801, and set flow control to none. To be honest, I don't know what this flow control means, but I do know the Chipsee industrial PCs can switch serial port direction automatically by hardware, so I shouldn't worry about configuring the transmitter-receiver direction manually. Okay, then we can call the init port method in the init state method to actually initialize the port. There is one very important step. I spent a lot of time on this problem. You need to set a delay when initializing the serial port with a timer. Otherwise, it will give you a serial port error number 16 of device or resource busy. Because the hardware is actual circuit, it takes time to start or stop operating. And then we import .async to use the timer class. And also we should close and dispose the serial port when we leave the screen. Because it's the hardware we are operating, we need to tell it to close explicitly. We can set it in the deactivate method, and we call super.deactivate at last, then write a port.close and the port.dispose. So now we have initialized the port, and we have also set a function to close the port when we switch away from the screen. We can now start to listen for incoming serial port signals. So how do we do this? This package has a serial port reader class, and it has a stream of uint at least according to the source code. You can listen for a stream in Dart with stream.listen. But to be honest, I don't know how to read it. I just search the keyword read in GitHub repo and find out if any other people have working code. This guy has a pretty nice and short code by reader.stream.listen. But anyway, we can read incoming data with a serial port reader and write a function start listen. Then we call reader.stream.listen data, and we use the data that comes with set state and add data to the received array. Well, because the data are uint 8 so we convert it to a string by string.from charcoals, and on arrow we don't do anything, we just print it for debug purpose. So let's also start listen in the init state, and don't forget to stop listen in the deactivate by calling reader.close. And in my opinion, if we operate faster than 500 milliseconds, we should also cancel the timer so that the port won't even be initialized. So far so good, right? Oh, there's a typo. It should be serial port flow control instead of parity. Let's test our code on our Chipsee HMIs. We can run this program in debug mode, and it will be installed through Wi-Fi to our 10.1-inch HMI with ADB. Now we can let the 7-inch device to send a hello Chipsee to the 10.1-inch device, and it's there on our scrolling list. We can clear the screen and test again. You should also notice there is a debug label on the 10.1-inch device. We can compile the Android app in release mode, and the performance would be even better on the Chipsee HMI. You can see the debug label is gone here. It's very responsive, and the animation is also very smooth. So that's it for this video. I hope you find it useful. I'm Gaofang. Thanks for watching.